Alright, we have hard problem today. We have to build a zigzag from LR range and n times size. The n 10 to the power of 9. So to think about this problem, let's think about example 1, 2, 3. Only 3 numbers, LR. Only one step. The first 1, 2, 3. First goes from 1 to 2, from 1 to 3, from 2 to 3 up, and this is 0 step. From 3 to 2 down, from 3 to 1 down, and from 2 to 1 down. The total is 6. The next step, only half of this would be enabled. So the yellow path continues to up, switches the direction. From 1 to 2, from 1 to 3, and from 2 to 3. And the red path go from 2 to 1, from 3 to 2, and from 3 to 1. And so in the first step we do in 2 directions, and in the next steps we only do half of these directions. And if we describe this in a matrix, it goes from up, from down to up, down to up. Yes, from okay, let's make it like this. Let's describe just the transitions from this first red. It goes from 1 to 3, 1 to 3, from 1 to 2, and from 1 to 3. This is an identity matrix. From 2 to 3. It goes from down to up. And let's describe yellows. It goes from yellows goes from from 2 to 1, from 2 to 1, okay, and from 3 to 1, and from 3 to 2. Let's this is identity all other zeros, and this is from up to down, and this is would be down to down, and it is zeros, and this is would be up to up, all zeros, because it's not enabled by the problem definitions. This is a matrix, and it describes how many ways we have enabled from each step to each other step. Basically graph, describe it, graph, traversal. And if we have many ways, we just do a multiplication, so m to the power of n will describe how many ways we have in the n steps. Okay, so what should we multiply to get the answers? So we have initial from number 1 we go up, from number 2 we go up, from number 3 we go up, then from number 1 we go down, from number 2 we go down, and from number 3 we go down. This is a identity matrix from, it's called DP, but it is a number of ways If we multiply it by transition matrix one time, it gives us an answer how many we have, how many ways total we have from each of these from one up we have this number of ways, from one down we have this number of ways. And if we multiply it by m again, we have do the second step, and it would describe how many ways we have from one up, and this would be one down in the two steps. And if we do to the power of n, we answer the question of the total size. Okay, and if we do finally, this would be some numbers a, b, c, d, e, f. We just do plus of them because each of them individually answers the question just for this number and this direction, and total would answer for all directions, all numbers. Okay, the final code looks like this. I didn't solve it myself and spent 50 minutes just to write from the other guy. This is the matrix of transitions. It goes 2m by 2m. We have 2m because we have combined states, not just transitions but also ups and downs. So this is like big transitions. Okay, and this is identity matrix for JP. It answers the question for each position 2s, because half goes up, half goes down, and it answers the question for this position going up, how many ways we have totally in n steps. This filling of the identity matrix, it fills it like this, and this is exponentiation of the matrix. It's nothing special, and it's well known. And finally we go sum and modulo. Okay, this was the hardest problem for me, and I think that's it for today.